welcome back to my channel. And I am Siddharth Valecha, and today we will discuss about regression modeling. So here we go. So firstly, we will see what we will discuss today. So firstly, we will see what is regression modeling basically is, and then demonstrate estimation model evaluation using R or Python. But we do in Python. Demonstrate stepwise regression with Python. Now, regression modeling. So, what is regression modeling? Regression modeling is a statistical technique used to establish the relationship between a dependent variable, which is known as target, and no or more one or more independent variables, which is known as predictors. Key types include linear regression, logistic regression, and extensions, such as stepwise regression for model refinement. Next, key concepts in regression modeling. So firstly, we will see dependent variable, which is target variable. This is the variable you are trying to predict or explain. It is a continuous in regression problems. And for example, predicting house prices, stock prices, or sales amounts. Next key concept is independent variable, which is also known as predictors or features. These are the variables that influence or explain changes in dependent variable. In a house price prediction, independent variable could include features like size, number of rooms, location, etc. Next is model. The regression model is built using historical data, and its goal is to find the best fit relationships between the dependent and independent variables. Now, assumption. Linear regression assumes a linear relationship between the dependent and independent variable, while other types of regression, for example, polynomial regression, may capture non-linear relationships. Next, types of regression models. First type is linear regression. In this simple linear regression, a straight line relationship between one independent variable and a dependent variable. Multiple linear regression involves more than one independent variable with a linear relationship between a variables. Next is polynomial regression, which extends linear regression to model relationships that are non-linear by introducing polynomial terms of the predictors. Next type is random forest regression, an ensemble method that builds multiple decision tree and combines their output for more accurate predictions. Next types are decision tree regression, uses decision tree algorithm to model complex relationships by partitioning the data into segments based on feature values. Next is logistic regression. So although it's used for classification binary outcomes, it's still referred to as regression because it predicts the probability of an event occurring. For example, yes or no or 0 or 1 outcomes. Next is rich and lasso regression. These are the variants of linear regression that include regularization terms to prevent overfitting by penalizing large coefficients. Rich use L2 regularization while lasso use L1 regularization. Next, steps in regression modeling. So first, data collection. Gather data that includes both the dependent variable and the independent variable. Next, data preprocessing. Handle missing values, outliers, and transform categorical variables if necessary. Example using one hot encoding. Next step is model selection. Choose the appropriate regression model based on the nature of the data. That is, we can say that linear versus non-linear, number of predictors, etc. Next is model training. Split the data into training and testing sets. Train the model on the training set to learn the relationship between the predictors and target. Next is model evaluation. Evaluate the model using metrics like mean absolute error, which is MAE, mean squared error, which is MSE, and root mean squared error, which is RMSE, or R square, coefficient of determination. Next is prediction. In this, we use to train model to make prediction on new or unseen data. Yes, now we will see it by running on Google Colab. So as you can see here, firstly regression model, we have estimation model evaluation. First we load libraries and data. So import pandas as PD, import numpy as NP, import train test split, linear regression, and mean squared error and mean absolute error R2 score. Then we load dataset by importing load diabetes from datasets, and data is equal to load diabetes df is equal to pd dot data frame data dot data columns is equal to data dot features name. df of target is equal to data dot target. Now, as you can see here, the data is loaded, library is loaded, and data is also loaded. Now, we split the data by x is equal to df dot drop, target axis is equal to 1, y is equal to df of target, x train x test, y train y test is equal to train test split, x, y, test size is equal to 0.2, random state is equal to 1, 2, 3. As we run this, this also splits the data and fit the model. For fit the model, we use model is equal to linear regression model dot fit x train y train. If we run this, yes, as you can see here, linear regression we- output. Now we evaluate the model predictions and is equal to model dot predicts x test. MSE is equal to mean squared error. Y test predictions. MAE, which is mean absolute error, and y-test predictions. R2 is equal to R2 score of y-test predictions. Print MSC of MSC, print MAE and MAE, and print R squared, the value of R2. Now, if we run this, as you can see here, MSC value will be 27 to 2724, MAE will be 42, and R squared will be 0.5675 to 0.5. Now, second is stepwise regression. So in this, firstly, we import necessary libraries as import SM from statsmodel.api. From sklearn.datasets, we import regression and import pandas at PD. This imports the pandas library. Now generate synthetic dataset. XY is equal to make regression, n sample is equal to 100, n feature is equal to 5, noise is equal to 10, random state is equal to 42. X is equal to PD dot data frame, X columns is equal to F feature I plus 1 for I in range X dot shape. X is equal to SM dot add constant, which add a constant column for intercept. Now stepwise regression function. Define step in this we define a stepwise regression function which is of name stepwise selection. X y threshold in 0.05 and threshold out is 0.10. Initial features is equal to x dot columns dot to list and selected features. While true, with the help of while loop, if changed is equal to false, or forward step is remaining features is equal to list of set of initial features minus set of selected features. New p-val is equal to pd dot series index is equal to remaining features. For new columns in remaining features, with the help of for loop, model is equal to sm dot ols yx selected features plus new columns dot fit. Now new p-val, new column is equal to model dot p values of new column. Best p-val is equal to new p-val dot min. If best p-val is lesser than threshold or in, then best feature is equal to new p-val dot idx min, and selected features dot append of best feature change is equal to true. Now, uh, now we discuss backward step, that is model is equal to sm dot ols yx of selected features dot fit. P values is equal to model dot p values dot ilog 1 colon, which exclude the intercept, and worst p-val is equal to p-values dot max. If worst p-val is greater than threshold out, then worst feature is equal to p-values dot idx max, selected features dot remove, which incites worst feature, and change is equal to true. If not change, then break and return selected feature. This will return selected feature. Now we apply stepwise regression as selected features is equal to stepwise selection xy, print selected features. Fit the final model. Final model is equal to sm.ols y x of selected features dot fit. Now we print final model dot summary. As if we run this, I already run this because it takes some time. So as you can see here, selected feature in the output, you can see here that selected feature, features 2, feature 1, feature 4, feature 3, feature 5, OLS regression result. Then you can see a dependent variable y. Dependent variable is y. Model OLS method least square, date Thursday 5 December 2024. And in this, if you see The feature to coefficient value is this, standard error is this, t is this, and if p is greater than t is 0, 0, 0. Otherwise, these are the nodes. R square is computed without centering, uncentered since the model does not contain a constant. And standard error assumes that the covariance matrix of the error is correctly specified. So here we completed our today's topic. And now, thank you for watching the video and please stay tuned for next concept. Thank you.